10 says find the slope of the tangent line, or sorry, find the slope of the line tangent to the graph of this function. Now this is an implicit function, and we know that the slope of the tangent line comes from the derivative. So we need to find the derivative of this function. So with implicit differentiation, we take the derivative of x terms, just like normal. So the derivative of 3x squared is 6x. And then here we actually have a product rule because we have an x times a y. So when I do the product rule, the derivative of the first term, 2x, is just 2 times the second plus the first term, 2x, times the derivative of the second. The derivative, when you're doing with the y terms, you have to apply the chain rule. So the derivative of y is 1, but then the derivative of the inside function is dy dx. Some people use y prime. Be careful with y prime, especially on a final. It's easy when you're doing algebra to miss those primes. So just, it's a personal preference, but I like dy dx just because I can't miss it when I'm doing the algebra. Then when we take the derivative of y squared, the derivative of the outside function y squared is 2y. The derivative of the inside function is dy dx. And this will equal 0 because the derivative of 2, you'll treat any constants like they're x terms, like raised x to the times x to the 0, so you don't have to worry about the dy dx when you have just a constant. All right, then using algebra, we simply solve this equation for dy dx. So I'm going to find all the terms that are attached to dy dx and leave them over here on the left side. And then I'm going to move anything that is not attached to a dy dx over to the right. So I have negative 6x minus 2y, and then dy dx is going to be negative 6x minus 2y divided by 2x plus 2y. Now we were told here to evaluate this at x equals 1. But if we look at our derivative, we actually have x's and y's in our derivative. So I'm missing some information. So to find the other half of this point, I'm going to go to the original equation and I'm going to plug in 1 and see what y equals. So I'm going to plug 1 in for x here, and I'm going to get 3 plus 2y plus 1, plus y squared, excuse me, equals 2. I'm going to write this so it looks like a quadratic, and then I'm going to move the 2 over, so 3 minus 2 is 1, so that makes all of this equal 0. This factors into y plus 1 squared, and we can see here that if we take the square root of both sides, y plus 1 is 0, and y equals negative 1. So 1, negative 1 is our point. So now I can come back over here and I can plug 1 comma negative 1 into my derivative. So negative 6 times 1 is 6. Negative 2 times negative 1 is positive 2. In the denominator, 2 times 1 is 2. 2 times negative 1 is negative 2. And this works out to be negative 4 over 0. Now what this means is that the derivative is undefined at 1, negative 1. So the derivative is not defined at that value.